You know, we've all just lived through a crash course in how fast a global crisis can spread. One minute it's a distant problem, the next it's everywhere. Well, believe it or not, something eerily similar is starting to unfold for our pollinators. So let's dive into this emerging threat, what some scientists are calling a pollinator pandemic.
But here's the thing, this isn't a new story. It's like we're watching a rerun of a disaster movie we've already seen. And that means we have a chance, right now, to get ahead of it, to write the emergency plan before the building is on fire. What if this time we could actually learn from our past mistakes?
To really get what we're up against, we have to rewind the clock and talk about the Varroa mite. Take a look at this timeline. After it was first discovered, it started to spread, and you can see how it just picked up speed. It took decades to cross Asia, but then, boom, it hits the Middle East, and in less than 15 years, it's torn through Europe and the Americas, leaving devastation in its wake. This is a stark warning of just how fast the dominoes can fall.
So you have to ask yourself, why are these mites so darn successful? Well, it all comes down to the honeybee colony itself. Because for a tiny parasite, a beehive isn't just a home, it's a 5-star, all-inclusive resort.
I mean, just think about it from the parasite's point of view. You've got perfect climate control, 24/7. You have an endless, year-round buffet of honey and pollen. And if that's not enough, the bees themselves are on the menu. And the best part? The bees have their own security force that protects the whole operation, and that includes the parasites hiding inside.
Professor Samuel Ramsey, who's really at the forefront of this new research, puts it perfectly. He says, you may not know it yet, but you want to live in a honeybee colony. What he means is, if you're a tiny organism looking for the absolute perfect place to live and raise a family, a beehive is basically evolutionary paradise.
Okay, so if hives are so perfect for parasites, how have bees survived for millions of years? Well, nature has a pretty simple but brilliant defense: social distancing. In the wild, colonies are miles apart. So if a parasite gets too aggressive and kills its host hive, that's it. Game over. The parasite dies out with the colony. But then, we came along. In modern beekeeping, we line up hives right next to each other. So when one hive collapses, the parasite just has to walk next door. We've accidentally created a superhighway that rewards the most destructive parasites.
And all of this perfect storm we've created, brings us to the new bad guy on the block, the new invader that's ready to take full advantage of the system we've built. Meet the Tropilaelaps mite.
Now, if you're a beekeeper, you know all about Varroa. But when you put Tropilaelaps side by side with Varroa, whoa. The differences are alarming. It's way smaller, so good luck spotting it. It leaves multiple feeding wounds, which creates horribly deformed bees, and it spends barely any time on adult bees, which means a lot of our current treatments just won't work. But the real kicker, the most crucial difference, is that it reproduces so much faster.
So how much faster are we talking? Well, a Varroa population doubles in about a month. Tropilaelaps, its population can double in as little as 7 days. Just let that sink in for a second. That is terrifyingly fast. It's exponential growth on a whole new level. And this is where it gets really chilling. Remember that timeline of the Varroa invasion we just looked at? Well, this new mite is on the exact same path. It's already spread out of Southeast Asia and is confirmed in the Middle East. It's like history is repeating itself, step by horrifying step.
But here's where the story changes. This time, scientists aren't waiting around to see what happens. They are on the front lines, racing against the clock to find answers before this invader arrives. So let's take a look at the incredible work they're doing to understand this new enemy.
Professor Ramsey's team in Thailand basically launched a two-pronged attack plan. They call it Sight the Mite and Fight the Mite. It's simple, right? First, you have to see your enemy and understand it. Then, you figure out how to beat it.
But that first part, Sight the Mite, was a massive challenge. I mean, this creature lives almost its entire life hidden away under a wax cap inside a bee cell. So how on earth do you study something that you literally cannot see?
Well, their solution was just brilliant. It literally started in a friend's garage. They figured out how to build a tiny little observation cell with glass walls, creating a window into the bee's nursery. They put this cell inside a custom incubator and filmed non-stop for the entire 12-day development period. And for the first time ever, we got a look at what this hidden enemy is actually doing.
And this all goes right back to that building on fire idea that drives Professor Ramsey. He's crystal clear about what happened with Varroa. He says, we waited until the building was on fire in order to start writing down an emergency response plan. We cannot do that again. This research,
All this painstaking work. This is them sounding the fire alarm before the disaster strikes.
Okay, so now that they could actually see the mite, what about fighting it? What did they learn? Are there any weapons in our arsenal that can stop this thing? Well, the results are a little bit of good news and a whole lot of it's complicated. Take a look at this chart from their treatment tests. You can see that formic acid, which is a pretty common treatment, had a really high kill rate for the mites. That's a huge plus. Heat treatment was also moderately effective, but the mite populations just bounced right back. So yeah, we have options, but as they found out, those options come with some serious trade-offs. And here's the big one, that formic acid, yes, it's great at killing mites inside those sealed cells. But, and this is a huge but, in the hot, humid conditions of Thailand, it also becomes toxic to the bees. It killed a significant number of bees and even queens. So, there's no silver bullet here. Not yet, anyway.
So where does all this research leave us? Well, it's that classic situation. We now know enough to be seriously concerned, but we also know that we simply don't know nearly enough to be prepared for what could be coming. And this opens up a flood of urgent, unanswered questions. First off, what are these mites even eating? Is it the bee's blood, their hemolymph? Or are they targeting the bee's vital fat body organ just like Varroa does? It's a fundamental question, and right now, we just don't know. And then there's this puzzle. These mites need developing baby bees, the brood, to survive. They die within a couple of days without it. So how in the world are they surviving long, cold winters in places like South Korea, where there's no brood for months on end? The answer to that will tell us just how far north they could spread.
And maybe the biggest question of all, the one that could stop this whole invasion in its tracks, how are they traveling? Are they hitching a ride on shipping containers, on commercial bee shipments? Because if we can figure out their travel routes, we might actually be able to stop them at the border.
And that's really the bottom line here. The time to get these answers isn't after the mite shows up on our shores. The time is right now. We've seen what happens when we wait. We have the historical precedent, we have the scientific warning, and we have a small window of opportunity. The question is, what are we going to do with it?